In this video, we are going to see how to factor polynomials by common factor. First, remember that to factor something is to express it as the multiplication of two or more things. In this case, since we are factoring polynomials, we want to represent that polynomial as a multiplication of two expressions, two algebraic expressions. To do that, we need to identify the common factor. And the common factor is the terms that multiply every term in the expression. So we need to find the common terms as in the coefficients and also the variables. So first, let's identify the coefficient that is common in the three of the terms. That means we want to find the largest number that divides into all of the coefficients. In this case, it's 15, minus 45, and 30. That would be finding the greatest common factor of the polynomial. So we check them and we see that the common factor between these three numbers is 15 because we can divide 15, 45, and 30 over 15 and get a whole number. Now we are going to identify the variables that are common in all of the terms in the polynomial. And the first thing that we see is that the three terms in this polynomial have x in them. X fifth power, x third power, and x second power. Now, since we are looking for the common one, we need to find the one that fits in all of the terms. So in the case of the variables, it's always going to be the one that has the lowest exponent. Okay, so in this case, fifth, third, and second, the lowest one is second power. So that will be the first variable in our common factor, x second power. Now, we also see that all of the terms have y in them. We have y sixth power, y fourth power, and y third power. Again, we must find the one that fits in all of them, so it's going to be the one with the lowest exponent, y third power. So that will be the second variable in our common factor, y third power. Now, since this is all of the terms that are common in all of the terms in the polynomial, this is what we call the common factor. This is what we are going to multiply times something else in order to get the original polynomial as a result. What we do is we are going to divide all of the terms in the polynomial by the common factor. First, we're going to divide the coefficients. 15 over 15 is 1, so they get canceled out. Now, the x's. If we have division of the variables with the same base but different exponents, what we do is we subtract the exponent in the numerator minus the exponent in the denominator. So for the x, it's going to be x fifth power over x second power. 5 minus 2 gives us 3. So the result is x third power because of 5 minus 2. Now, since both of them have y 6 minus y third power, 6 minus 3 is 3, so y third power. Okay, so that's the result of the division of the first term. Now, we are going to divide the second term. Minus 45 over 15 gives us minus 3. Now for the x, the exponent. 3 minus 2 gives us 1, so we don't write it, the exponent. Now for the y, 4 minus 3, also 1, so we don't write the exponent. That minus 3xy would be the result of the division of the second term. Now we are going to divide the last term. 30 over 15 gives us 2, because 2 times 15 is 30. Now to divide the x's, x squared over x squared cancels out because it gives us 1. And y third power over y third power again cancels out because it gives us 1. So the result of that division is 2. And with that, we would be finishing factoring our polynomial. Now, in order to check if we did it correctly, we would solve the multiplication and check that we get as a result what we had at the beginning. But before we do that, let's see how to solve this factorization without having to solve the complete division like we did it right now. What we can do is see the division in a different way. In order to find the second product of the multiplication, what we can do is ask ourselves, what do I have to multiply the common factor by in order to get each term of our polynomial? So we're going to start with the first one. 15 times what gives us 15? 1. So right now we won't write coefficient 1. We continue with the variables. X second power times what gives us x fifth power. So x third power, because 2 plus 3 is 5. Now y third power times what gives us y sixth power. It's going to be y third power, because 3 plus 3 gives us 6. Now our second term is negative, and we have a positive, so I know I'm going to have to multiply it times a negative term to get minus 45. 15 times what gives us minus 45? Times minus 3. So we write minus 3. X squared times what will give me x third power? Well, times x, because x squared times x is x third power. Now, y third power times what gives us y fourth power? Well, why? Because 3 plus 1 is 4. Now I found my second term. Now to find the last term. 15 times what gives us 30? Well, times positive 2, because 15 times 2 is 30. Now x. X second power times what gives us x second power? So it's times 1, so I don't write it. And y third power times what gives us y third power? Times 1 as well, so we don't write it. And we are done factoring. We got the exact same answer we got before. To check, what we do is we are going to solve the multiplication. First, we multiply our common factor times the first term in our second product. 15 times 1 is 15. X squared times x third power, x fifth power. Y third power times y third power is y sixth power. Now positive times negative, negative. 15 times 3 is 45. X squared times x is x third power. X third power times, y third power times y is y fourth power. Now with the last term, 15 times 2 is 30. And since we don't have variables with 2, we keep the same variables we had in the first term, so x squared y third power. Okay, and as you can see, we got the same thing we had originally, so our factorization is correct. Now let's solve another example. We have coefficients 9, 27, and 3. The common factor in this example is 3, because the 3 numbers are divisible over 3. Now we check which variables we have common in every term. So the 3 of them have m and n in them, but we need to check the lowest exponents. So since we have m squared, m seventh power, and m fifth power, the smallest exponent is second power, so m second power. Now with the n's, and third and fourth and second will be the smallest, and second power. So that is our common factor. Let's find the second product that we need to multiply by in order to get our original equation. 3 times what gives us 9? Times 3. M second power times what gives us m second power? Well, the same number, 1, so we don't write it. N second power times what gives us n third power? Well, times n, because 2 plus 1 is 3. Now let's check with the second term. 3 times what gives us 27? 9. So plus 9. 3 times 9, 27. M squared times what gives us m seventh power? M fifth power, because 2 plus 5, 7. Now with the n. N second power times what gives us n fourth power? N second power, because 2 plus 2 is 4. Now for the last term, 3 times what gives us 3? Well, times 1. we won't write the coefficient to check if we have variables. M second power times what gives us M fifth power? Well, M third power, because 2 plus 3 is 5. And now with the n's, n second power times what gives us n second power? Well, times 1. We don't write it because it's already implied as the coefficient of m third power. So this is the result of factoring by common factor our polynomial. Okay, just to be sure, we are going to check that we do get our original polynomial when we solve the multiplication. 3 times 3, 9. M second power, n squared times n third power. It is the first term. Now our second term. 3 times 9, 27. M squared times m fifth power, m seventh power. M squared times n squared, and fourth power. Now the last term, 3 times 1, because 1 is the coefficient of this m. We don't have to write it. It's implied. 3 times 1 is 3. M squared times m third power, m fifth power, and n squared times 1, n squared. We check, and we did get the 3 terms we had in our original polynomial, so our factorization is correct. Let me just erase this one that I wrote, because the coefficient 1 is not written in a term. Now let's see a last example. We have a binomial that has only one variable in each term, and it's common in both of them. So in this case, we only have to identify the variable with the lowest exponent. In this case is 3. That will be our common factor, and we write it as a common term, x third power. Now to write our second product, x third power times what gives us x fifth power? Well, x squared, because 3 plus 2 is 5. And x third power times what gives us x third power? Well, times 1. Since we don't have more variables, in this case, we do write number 1, because we're not going to multiply times any other variable. Okay, so now let's check if it's correct. X third power times x second power, x fifth power. X third power times 1, x third power. It is what we had at the beginning, so our factorization is correct. So this video was how to factorize polynomial by common terms. Thank you for watching this video.